Hello and welcome to this third video, the third in our series, the Java course. So this video will be covering data types as well as operators in Java. So Java, from the previous video, we learned that it's a typed language, and it means that whatever statement that you as a Java programmer can write, or if you want to declare variables, they have to belong to a certain type. So we have to understand what these types are, hence data types, as well as certain operators that can enable you to work or implement certain operations in the Java programming language. So in this video, I think it will be broken into, I'll make two videos, right? So the first one will end on variable scope and rules, and then the other part. So this video, this will have two parts, part one and part two. So in part one, we'll look at primitive types, literals, variables, and variable scope rule. Okay, so it's Charles Mubanga here at Thriving Code, and I urge you all to subscribe to the channel, show some love, hit the like button so that we can get this channel going. Stick around and thank you. So data types, what are they? Okay, so we can look at the importance of data types. We are taught that they are vital because Java is a typed language. Okay, so it means all operations are type checked by the compiler for compatibility, for type compatibility. Okay, so Java has two types of types, or two categories of types. We have object-oriented and non-object-oriented types. So the object-oriented types, those come from classes. Okay, so we can create a variable of a type class. Okay, and then we have non-object-oriented types. So let us look at the non-object-oriented primitive or types. So what are primitive types? We are taught that they are types that are also called elemental or simple types of data. So the first type of primitive, right, are what are known as integer types. So integer types include signed positive and negative values, right? So let us look at this, okay? This table here showing 4 types of integer types. So we have byte, which has a width of 8 bits, okay? So, and then we have the short, which is also an integer of 16 bits wide. Also an int, which is a data type int, has 32-bit. Also we have a long, which has 64-bit. So you see the range, okay? The range here is from negative values, negative 128 to positive 127. So the byte can accommodate values in this range, okay, from negative, okay, to the negative and as well as positive values. So the short 16-bit width type has also this range or capacity in short. So the int has this capacity, all right, and then the long also has this capacity, okay? So from here we know that if you want to have, for example, to work with, if you want to add maybe 2 plus 2. So in Java, you have to use types, or you declare variables, all right? Okay, so let's get back. Sorry, we consider an example, okay? So let's look at an example, okay? Let's look at an example. So let's look for the example. So it's this one. Okay, so we have an example here, which is showing the int type. Okay, so we have not, we don't have, so we have picked the int integer. I mean, rather the int primitive type, okay, of type integer. So the example is quite, it's not that big at this stage. It's just okay. So we have the first line of code here, which is the import. So we have java.youtube.scanner. So we are importing this scanner class from this package Java, okay, and then from the YouTube package we are importing the scanner class. So we know that a class begins with a public class, or it can just be begin with class. By default, the class is public. Okay, so int type is our class. We have our main method there, and then we are creating the object input from the scanner. Okay, so we have scanner input equals new scanner, and we call the system class, you know, for us to be able to access our machine's system, and then we call the in object. So we have this object as the parameter in this object creation code. So we have created the object input so that we can be able to use the input object to input data from our console. Okay, so we have these three variables, int number 1, int 2, and int sum. So the first, this line will enter the first integer, and then this line number equals to input, we call the next int method. So this will read the first number from the user. So this line of code, this next int will pass the value into this scanner object, and then it will be stored in the variable number 1. So we have initialized our variable number 1 by that way, by using the console. So the second also is just the same. We can use the print without ln, which means that the cursor cannot go to the next line. Okay, so we have the second integer being called here, and then next int is passing the value that will enter on our console into this object, and then the object assigns it to the number 2 variable, and then sum will say sum number 1, which is our variable, integer variable, plus number 2. Okay, and then we have system out dot printf. Printf is format. So we are we are printing formatted text. So we have these delimiters indicating that we are printing a decimal number. Okay, we are printing a decimal number. So let's check our console so that we see how we can run the code. So we cd onto the desktop, we cd onto YouTube, then we cd onto to YouTube, we cd. Okay, let's check first what's in YouTube. So we have core Java. Okay, so we cd onto core. Okay, we cd onto data. I think it will be found. Okay, so under here, when we check, we have our right here the int type. Okay, our int type.java file. So we can clear this up, and then we compile our file, our Java file. Okay, so we have called the Java compiler. It has compiled. So if we check, we have the int type.class. So it has been compiled. So let's try to run it. Java int tab. Okay, try to run it. So enter the first integer. So okay, so this is the first line that has been called. Okay, so we enter our first integer. So we can say 25. We enter, and then we can put in the second, right? So the sum is 105, and then it's okay. The program is released like that. So we've found the sum of our value. So we can call it again, right? Enter. We say 1 plus 1. So the sum is 2. Okay. So we have demonstrated here that the main purpose of this example is just to understand how this integer type can be used. Okay, so this is, you can try this example on your own so that you get a clear understanding. Okay, so let us look at the next type, which is the floating type. Okay, so the float is not an integer. So the float is a type that includes these two types. The float itself, we say floating point types. So floating point types include the float, which is 32 bits wide, and the double, which is 64 bits wide. The types which represent single and double precision numbers. So we have fractional values, for example, being represented by float and double. Okay, so double is the most commonly used. For example, when we use this square root method of math class, it returns a double. Okay, so let's look at an example. Okay, let's look at an example here. Let's look at an example. We open a file. that will demonstrate the floating type. Okay, can see it. Where is it? Okay. Okay, maybe it's this. Let's try this. Okay, yeah. So this is the program that demonstrates a floating type. Okay, so the double, as we were told, that it's the most or widely used floating type. Okay, so our comment is saying the program demonstrates the Pythagorean theorem by finding the hypotenuse. So we can find the hypotenuse by writing our program in this way. So the double variables are being declared. We have x, y, and x like that, really. Okay, so I think we don't need this one. We don't need this one. Okay, so we have x and y. So x is initialized to 3 and y is initialized to 4. So if you see, these are not floating point values, okay, because our data type is double, okay, hence it should be in decimal form like that. So a double should appear like that. Okay, should appear like that. Now this is an int in an integer number. So now we will see what this method, square root method, will return. So the variable z, okay, we need z. Okay, we need z here, not x. So we need z so that we don't run into issues. Okay, so the variable z is here, okay, and we are initializing it by doing a dynamic initialization. We'll get to know what that is. Okay, so you can initialize a variable by doing this. So we say this is actually what we do. So the square root of x times x, okay, x squared, right? And then y squared, okay? So we are using the asterisk there, plus y times y. So this is, if you can see, the square root method is preceded by the name of the class of which it is a member. So square root method is a member of the math class. We don't need an import to use the math class. So we are told that not all standard methods are called by specifying their class name first. Several are. Okay, so we should take note of the comments. So you see how why comments are important. Okay, so now when we say system.out.println, okay, we want now this string to be printed and our value for the hypotenuse to be printed. We can do that by going to the console again. So since we did some changes to this code, so we hit save, Control S, okay, and then go to our command, and then we say javac Okay, then we hit enter. Okay, we have compiled our program. So we say Java iPod, and then we say enter, right? So the hypotenuse is 5.0. So 5.0 is a double. Okay. While these operands, okay, the values for these operands or for the variables x and y are int type, but the math square root returns a double. So what we have seen here is a double value being printed out. So this is how you can use the double type or floating type data type. Okay. All right, so let's get going. The characters. So in Java programming, if you want to print out characters, like single characters, okay, you can use, there's a data type which is available for them. So in Java, we have the char type, which is unsigned, 16-bit type, having a range of 0 to 65,520, 35. So Java uses the Unicode, the universal code that defines a character set that can represent all of the characters found in all human languages. So what is this Unicode? So, right? Okay, do we have an example for this? We've just gone to Boolean. Okay, so I think we have an example. So let's look at the character type right there. Okay, so let's open our new file. So this should be this one. Okay, so this is the character. So in Java, characters can be even handled in a manner we handle integers. So we have this class character arith demo. So we have declared our variable ch. So ch can be initialized by single quotes, and then we've put x there. So x is now ch. Okay, so a character is put in single quotes. So you cannot have, okay, you put a single letter like x. Okay, so this is a character, right? So here we can print our character. So we say ch contains ch, so x will be printed. And then we can increment. Okay, so by incrementing, we are adding the value 1 to ch. So ch will move, all right? So if we move up to print ch right now, I think x, what letter follows? It should be y. So y will be printed next, right? So y will be printed because we've incremented x, right? So ch can be assigned the value of z. So the Unicode, using the Unicode, 90 is z, right? So when we print ch, it will be z. Okay, so let's head on to our we say Java. What was that? Something like this. Yes. char arith demo. So when we compile this class, we have, okay, could not load main class char arith demo. Okay, what could be a problem? Character arith demo. Okay. Okay, so we didn't compile it. So we say we call the Java compiler first. Then, all right. So first we compile, and then we can run. Okay, so you cannot just call the interpreter like we did here without compiling. So you get this error, could not find or load main class. Arith, whatever. Okay, so we can now run our program. Okay, so like I was saying, we have our variable ch containing x at first, and then we have a ch is now y. So we incremented by incrementing, adding two double plus signs is incrementing. This is the post fix increment, right? So, okay, we'll get to know what this is, all right? We'll understand it better. So that's why we can see that ch is now y. So we added we moved it to the next place, okay? So ch is now z. So we assigned ch to 90 to ch. So 90 is the Unicode value for 90. Since this variable is a char, it's a character, so, and it's rated to Unicode, so the interpreter understands that. So this is the data type character. So that's how you can work with character data type. All right, so the Boolean type. All right, so Boolean is also a data type in Java programming. So this type represents true or false values. Therefore, a variable or expression of type Boolean will be one of these two values above. All right, so we have also a true or false data type that can be used to work with expressions that in which you would want to find the true or false. Where you would want to get a true or false answer. Okay, so let's look at this example where we'll get to see how the Boolean can be used, right? So we open our file. We have boo demo, should be our file we are looking for. Yes, it is. So program below demos Boolean values. That's our comment. So we have the class boo demo, the main method. We have our variable Boolean b. Okay, so b is initialized to false at first. So when we say we want to print it out to the console, b will be false. So next, b is initialized to true. When we print it out, b will be true. So a Boolean value can control the if statement. So the Boolean variable is sufficient by itself to control the if statement. You don't need something like if b equals to true. So if b, for example, here is set to true, then the interpreter knows that b is true already. So it can be used in the if statement. So if we say if b system.out.println, so this will be executed because b is true right here. Okay, so you can use even Boolean types in an if statement. as long as it is set to either true or false, and then you want something to be done in your code, so that can be done. So if you set B to false, then you say if B, right? So if you, when you look at this, the interpreter will forget the value that B has here, well, as long as the condition is met and the code is executed. When you initialize it, it will not pick this B, which is true on top. It will be the B, which is false. So okay, if B system.out, this is not executed, so B is false, so this is not executed. Okay, that's what the code is saying. So now the outcome of a relational operator is a Boolean value. So we can try to see also how we can use a relational operator like the greater sign, okay, a greater than sign. So we are using it because these are related values. They are all int types. So okay, so when we say system.out.println 10 is greater than 9, and then this, if this is true, and then it can, the answer will be true. Okay, so when we use a relational operator like in that way, we get a Boolean value. So let's try to run this class. Okay, so we clear this up. We say Java compiler demo. We compile it. Okay, it has compiled. We try to run it. Okay, so we have B is false, B is true, right? Right here, B is false, B is true. Okay, and then we have this is executed. Okay, and then this is not executed because it's false, right? And then we have 10 is greater than 9. 10 greater than 9 is true. So this right here, we are putting in brackets. So we're just telling the compiler where to put priority. So just like in our algebra, okay. So we start with these values in brackets. So this is about the Boolean data type and how you can use it. So let's head on to our slide. Okay, so the literal data type is just a representation of constant values. So as I was saying, we have 12, which is of type long. If you want a constant of a long type in your program, you just represent it with L in front of it. So equally, if you want to use float type, you just put an F in front of your value. Okay, so let's head on to the next slide. So we have character escape sequences. So in Java, we use these escape sequences in our programs. So in that integer example we saw that we used those decimal delimiters, right? So let's look at what these are. Now we have a single quote, right? So a single quote, in single quotes, okay, forward slash, backward slash, single quote, we have a double quote, we have a backslash, okay. We also have a return escape sequence represented with a backslash R. So this means that the position of the cursor is put, okay, the carriage return positions the screen cursor at the beginning of the current line and cannot advance to the next line. Okay, so we have the new line. Okay, so you can use this inside your println method to have your text moved to the next line. So the form feed, okay, a \f, that is the form feed. You also have the \t, which is the horizontal tab. So that tab on your keyboard can be used in your program with this escape sequence. We have \b, which is the backspace. We have this \ddd, which is the octal constant, where d can be in form of this octal value. All right, where ob, okay, meaning this is an octal constant. So we have also this u xxx, okay, which is an hexadecimal constant which can be written in this form. So 0xff, which is just the same as 255 constant. So these are your escape sequences that you can use in your Java program. Okay, so let's look at an example. We see these sequences, escape sequences in action. Okay, so let's look at this example. We have something like escape 6. Yes, this is the one. So we have this class here, escape 6, which is in the main method here. We have these strings being printed. So the first sequence to use is \n. So meaning when we put \n here, this sentence will be broken into two. So first line on top, and then second line will be pushed down in your console. Okay, so this one, the double backslash, is a directory. Okay, so when you want to show the directory of a file, for example, when you're working with input output streams, so you can use the backslash, double backslash sequences in your program. So we have the double quote. So you see how double quotes are used. Okay, so in quotes will be in these two double quotes. Of course, don't forget that you are outputting a string, so you see the same is within these two double quotes. So we have the \t. So this is the tab escape sequence. So it will move to create some space between ABC. Okay, so let's hit Ctrl S in case we didn't save this file, and then we go to the command. So we call the Java compiler. We say what was that? Okay, escape, right? Okay, .java. We hit enter, and then we compile. Our program is compiled. We call the interpreter by okay, and then we run it. So you see first line and then second line, because we had used the \n sequence, escape sequence. And then we have the directory. You see directory sounds. So we have this in quotes in these two quotes, and we have these letters ABC shown with this space in between. So this is the tab space. So these are escape sequences that you can use, okay, in your program, and many more. There are quite a number, so you need just to have time to go through them and get familiar with them. So let's go to our slide. Okay, we are back at it. So we have variable dynamic initialization. Okay, so we are looking literally at variables. Okay, so what are variables? So we know what variables are, of course. So variables can be typed. We say int variable, double. Okay, so with dynamic initialization, in that example of finding the hypotenuse, we saw how we initialized our z variable using the square root method of type math. Okay, so that is dynamic initialization. So Java allows variables to be initialized dynamically using an expression as long as it is valid at the time the variable is declared. So let us look at an example that is showing this variable dynamic initialization. Okay. So I can't see it. Okay, dynamic init is our file. Okay, so we see okay, the program here, it's saying we are demonstrating dynamic initialization. So we have these two variables of double type, radius 4, height 5. So volume, we are trying to find the volume of okay, so of this cylinder. So we are trying to find the volume of the cylinder. So we say double volume, since we didn't declare it on top, so we declare it. You see, volume is not up here on top, so we cannot just start with volume. So you have to declare your variable, so volume, and we dynamically initialize it. Okay, so this is relevant at this point because, okay, so we say volume equals to pi times radius times radius, so it's radius squared times height. Okay, so we say we want to output this on our console. We say volume is, then there's like a space here where we just to create some space, so we call the volume, and then we'll see our volume for the cylinder. Okay, so let's try to run this program. We say Control S in case we didn't save it. So we clear this up. We call the compiler. Which file is that? Dynamic.java. Okay, so we call the interpreter. Okay, so the volume is 251.328. Okay, so the thing to note here is this dynamic initialization that we can see here. So that is the most important thing. We are not showing the double, how to work with doubles, but we just want to take note of the dynamic initialization taking place. Okay, so let's go to our slide. Okay, so we are here. We have another thing to look at under variables. So we are looking at the variable scope or the lifetime. So a variable has a scope. It has space where it can be used. okay, in a program. So okay, so we are saying Java allows variables to be declared within a block of code. So when you for example, the main method starts with the curly brace opening and closing, so that is a block of code. Okay, so we are saying a block defines a scope. So everything that is within the opening and closing curly braces, that is a scope. So variables that are in that scope can be used and within that scope. So all right, they cannot be called by a method, for example, out of the scope. So a method with parameters includes them in its scope, right? So that's what we are looking at here. So the second rule provides the foundation of, the scope rule provides the foundation for encapsulation. Okay, so encapsulation basically looks at hiding data and functions of a program or a class. So in this, as we progress, as we move forward, we'll look at encapsulation. It's an important concept in Java programming. Okay, so it's very useful. So a scope also provides the foundation for encapsulation, because everything within that scope is hidden to the outside code. So scope can be nested. We are told scope can be nested. So this means that objects declared in the outer scope will be visible to code within the inner scope. Okay, so the main method, if you happen to put a method inside the main method, whatever objects and variables that are out of that second method you've put in your, for example, main method can be still accessed. Okay, so that's what this sentence is saying. However, the reverse is not true. So if you have nested you have blocks, you've nested your blocks of code. Okay, you've nested your methods. The inner method cannot review its variables to the outer method. So let's look at an example that is showing the variable scope. All right, so let's look at this example right here. We check, we open, no. Okay, so we say open file, we look for scope, something like scope demo. Yeah, so this is our example. So program demos are block scope. So we have this scope from here, you see, up to here. So this is also a scope, the class scope, which is the scope demo. So everything that is within this class scope demo can be accessed by the class. So when we go to this main method, so it also has a scope of its own. So we have from here up to here. So this is whatever is within the main method is within its scope. So we have this variable of type integer. It's known to all code within the main method because, okay, it's within the main method's scope. So when we initialize x to 10, and then we use the if statement to say if x is equal to 10, and then, so you see, we are not using this equal. So when we are comparing, we are using double equal signs. So it means we are comparing. Take note of this. So start the new scope. So this is the new scope that is being created. So this is nesting I was talking about. So within the main method, we can also create another scope, and within the if statement, we can also create another if statement if we want to nest. So what are we saying? For example, when we look at this integer variable y, it is known only to this block. So it is known only to the code within the if statement. So the main method does not know y, which is 20. Okay, but x, which is out of the if statement, is known even within this if statement. So when we say system.out print x and y, we can print x and y because the rule is telling us that the variable out, which is in the outer scope, is known to the inner scope, but the reverse is not possible. So this outer scope, knowing what is inside this inner scope, is not possible. Okay, so we can say x, which is, we say x equals to y times 2. So this variable is being used. We can use it again. So this will give us I think 20. I mean rather 40. Okay. So when we say y equals to 100, error here. So y is not known here. So y is out of its scope because y is not declared in the outer scope. So let's try to compile and run this program so that you get to understand what that actually means. So let's try to call the compiler. We say scope. Okay, we try to compile it. Okay, so we have a compile time error. Okay, see, so and it's being flashed right here. We are told that cannot find symbol y. So error. So we even have this comment being output here. So symbol variable y in the location class scope demo at line 19. So we are okay. So it's not known in the main method. Okay, so the main method does not know the variable y. So let's get here and we just try to comment it out. We hit Control S, we save it, we call the compiler again, we compile, and this time it has compiled because we've taken care of that, and we can call this class again and try to run it, and we are saying the first line is just printing x and y. So x is 10 and y is 20, then x is 40. Okay, so this is the variable scope. So we should understand this. It's quite important. So it brings out confusions if you tend to forget about this. Okay, so let's head on to our slide again. Okay. Okay. So let's look at the variable's lifetime. So a variable also has a lifetime. We are told that when a variable is created, so variables are created when their scope is entered. So and destroyed when their scope is left. So a variable's life is determined by its scope. So if a variable scope is entered, then the variable is created and is left and destroyed when the scope is exited. So we are told that this means that a variable will not hold its value once it has gone out of scope. Not variables declared within a method will not hold their values between calls to that method. Okay, so we should take note of this. So variables that are put in a method, once the method is called and everything is done, those variables die within that scope. So it's important to put variables that we want to use throughout the program on the top part of the class. Okay, so those can be called local variables. No, rather, they are not local. Local variables are the ones found in within the method. Okay, so let's consider an example where we'll see the variable's lifetime. Okay, we should also take note of that no variable declared within an inner scope can have the same name as a variable declared by the enclosing scope. Okay, so let's look at this so that we get to understand what we are talking about right here. So let's look for that file. We have scope demo, so we should say side effects. We have var lifetime. I think it's this one we're looking for. So we have this variable out here, which is declared on top. So this variable is known to everything within this scope, but the y variable is not known here. So we have this for loop. We are saying int x, and then we say for x is initialized to 0, and then x is less than 3. We increment the same x. So this is a loop. So when x is at 0, it will evaluate this condition, and then it will increment, and then it goes to the next. So int y equals to -1. Y is initialized each time the block is entered, right? Because it is within. So once the block is exited, y dies. So once again the block is entered, y is initialized. So this is the lifetime of a scope that we're talking about. Okay, so y is within the scope, and which is the for loop. So it's a loop to keep on. It will be looping for, I think, 3 times. Okay, so system, we print it out. We say y is, it will print this. This will always, it will print y is -1, and then y is now initialized to 100. So we say y is now 100. Okay, so it will keep doing that. So let's try to see what the program is all about. So we call the compiler zip var. Okay, var lifetime. We compile it. Okay, it has compiled. We call Java interpreter. Then okay, so this is the for loop in action. So it has printed 3 times this. So y is -1, and then y is now 100. So we are looking at y being initialized each time the loop is entered. Okay, so it's not changing. So it's just incrementing, meaning to go to 3 times like that. That is what the condition here is saying. So this is a demo of the variable scope life. Okay. Okay, so thank you for sticking around, and this is the part 1 of this tutorial, or this presentation on data types and also on operators. So the part 2 of this video will start with operators. So it will be based on operators. Thank you so much. Kindly subscribe and hit the like button so that we can have this video even reach other people.